Good morning. Today we are talking about our second energy pathway known as fermentation. Fermentation is known as an anaerobic process. It does not require oxygen in order to work, like cellular respiration that we talked about before. It also starts with glycolysis. So that's something that the two reactions share in common. Because it starts with glycolysis, it's going to make per glucose a total of 2 ATP. It's going to run glycolysis in a similar way. That's what you net. 2 ATP is what you net in cellular respiration as well. And there are two common kinds of fermentation: lactic acid fermentation and alcohol fermentation. So let me show you what I mean by those particular kinds of fermentations. Lactic acid fermentation starts with glycolysis. So remember, that's where you take the 6 carbons in glucose and you split them into 2 pyruvates. And glycolysis, when we do the splitting of our sugar, we still have to invest 2 ATP. We make 4 total ATP, but we often will write this as a net of 2 ATP gained by the cell, right? Because this is the ATP that you can use for your energy. When we do this, we also make this electron carrier. And unfortunately, our cells can't just sit on this primed electron carrier. We have to use up that electron carrier. So one way that cells can do this, if you're just doing fermentation, is they can use a secondary step and change this pyruvate into something else. And in the case of humans, when we don't have a lot of oxygen around, we can flip into lactic acid fermentation temporarily, not long term, but temporarily. Like think of a sprinter like Usain Bolt, right? At the end of a race, has probably flipped into this fermentation. And we can flip into fermentation and we can reset our NAD by producing lactic acid. So changing the outside H's and adding like sort of an H group to this acid gives us lactic acid. And lactic acid is what builds up in our muscles. It causes that burning sensation when you're like doing lots of reps, right? And lifting weights and then those sore muscles afterwards. So while humans cannot do this long term because it wouldn't be enough ATP to run all of our like trillions and trillions of cells inside of our bodies, we can flip into it temporarily, run it short term, especially in times when we're low on oxygen. And then once our body recovers and we get our oxygen under control, we'll flip back into cellular respiration. So lactic acid fermentation is one kind of fermentation, but alcohol fermentation is another that we use a lot when we make alcoholic products like wine and beer, and when we make different sorts of yeast products like breads and things like that. And so again, glycolysis is going to split our 6-carbon glucose into 2 3-carbon pyruvates. This is going to net 2 ATP for our cell, but we have to reset this NAD. And in alcohol fermentation, yeast reset this NAD by creating an ethyl alcohol. So by sort of sticking on an alcohol group and creating an alcohol. For beer and wine and our alcoholic products, we're actually then going to distill or separate that alcohol from the rest of the different products inside of or being made by yeast. And then we're going to like sort of process that. For bread, we're actually interested in, if you see here, this process also cuts off a C or a carbon group and creates some CO2. And for breads, it's that CO2 that allows them to rise, right? And so to space out our sort of cells and to see the bread actually rise. So breads, we're going to actually use that CO2 as well to do part of that particular process. Now, I want you to be able to compare cellular respiration to fermentation. The two are similar because they both build energy for our cells. The two are similar because they both start with glycolysis as step number 1. And both of them, glycolysis is going to create a net of 2 ATP per our 6 glucose carbon that we're like sort of starting with. However, cellular respiration has 3 additional steps to it. Fermentation only has 1 additional step. And in cellular respiration, those 3 additional steps allow a cell to gain 32 ATP per glucose, whereas fermentation, doing that second step, doesn't really gain any more sort of ATP. So the cells are only going to net 2 ATP per glucose. Cellular respiration, on the other hand, some of the negatives, you have to require a mitochondria to do all 4 steps. Oxygen is required to do that last step, but that's where we make most of our ATP. So we say the whole process is aerobic. And only eukaryotes would be able to do all 4 steps because a mitochondria is an organelle, right? So that would be something that you would only see in a eukaryotic kind of cell. Fermentation makes less energy, but you don't have all this setup. So you don't have to have an organelle, you don't have to have a mitochondria, you don't have to have a breathing system where you're requiring oxygen to make it to your cell. And so this is kind of a simpler way to get energy. You're still making energy. And so both eukaryotes can do this, but also lots of prokaryotes do something like this as well. That's all I want to say about fermentation. See you next time.